Morning. Today I will talk about Newton's applications, and we will here stop ignoring friction. Then we are going to start now recognizing that there is really frictional forces, and when we talk about frictional forces, we are talking about a force that has its basis in surfaces that are not smooth or completely smooth. Then we are going to look as if there is bumps in this is surface 1, and there is another like dips or bumps in the second one, and then they're gonna, I would say, click when they are going to move or attempt the motion. Mainly we have two types of friction. The first one is kinetic, and that is, we call it sliding friction, and this is when we have objects in motion. The second type, we call it static, and that is when the object is stationary and it is always opposing motion. And we will talk about a thought experiment that we usually will do in the case of friction. Let's say I have an object that is sitting here on the surface of that is rough, okay? And I will apply a force. Okay, I will apply a force here, and I'm gonna call this F applied, and I'm gonna form a table here. Okay, now here I will say F applied, and this is in newtons. Here I'm gonna talk about FF, the force of friction. Here static or kinetic. And I want to add another column here, say motion, no motion. Then what I have here is, when I have zero force applied, the zero force of friction is zero, and here, of course, not applicable. Now let's assume here I have 5 newtons and no motion. The object did not start motion. Then it's very clear that because no motion, sigma F equals 0, then also force of friction is 5 newtons, and since the object is not in motion, then this is static. I'm gonna continue here working on this. Now, the next one, let's assume 10 newtons and also no motion. This is going to be 10 newtons and also it is static. And then now let's assume this is 15 newtons, no motion again. And this is 15 again, and this is static. Now let's assume that at 17 newtons, the object was on verge, we call it, of motion, like about to move. Here we will still talking about static, and that is 17 newtons, and we will say this is the maximum value for static friction. After that, I might have my object in motion with only 16 newtons, and that is gonna be the force of friction. We're gonna talk about that, and that now it is kinetic and there is motion. Okay, then I might keep that 16 newtons to keep the motion. If I will attempt to graph that, this relation, if applied in newtons, and this is if F in newtons, I want to do the opposite. Oh, this is okay, and then here, let's say 5, 10, 15, 25, 10, 15, and 20. And then here, this is my first point, this is my second, this is my third, and we said at 17, like almost somewhere, 17. Okay, and then 16 is somewhere here. Then my graph is gonna look something like this. Okay, now here, this is, we call it Fs maximum, static maximum, and that is mus times the normal, and here we call this Fk, and that is muk times the normal. Now, what does that mean? This means that the force, the static, F static, can be any number, okay, from, okay, equal to mus normal. This is its maximum to 0. Like it can start from 0 and it can reach mus normal times the normal force. Whereas Fk, it has just that value. Now we call mus coefficient of static friction. It has no unit, and muk coefficient of kinetic friction, again, no unit. Here I want to remind you that normal is not always mg, because we have situations where it might be equal to other forces. I can say, let me give you like the easiest one so that when I have my object on an inclined plane like this. Okay. We will say here that I need to draw a free body diagram for my object. Then I'm gonna make it slanted. Okay, and then here I have the weight mg. I have here if, let's say, k. Okay, and I have here the normal force. Okay, now I don't want to solve a problem here, but I want to say if this is your theta, this is your theta, and this one is mg cosine theta, and this one is mg sine theta. If I want to look only at the Fy, sigma Fy equals 0, I don't have any acceleration, then normal minus mg cosine theta equals 0, and the normal here equals mg cosine theta. This is one of the cases where I will, then if I wish to calculate what's Fk is going to be mu k times the normal, and Fk will be mu k times mg cosine theta. Then this is one of the cases where we don't have like that normal equals mg. Okay. Now we cannot have, I will say, exact values for the friction whenever we are going to measure the coefficients of kinetic or static friction. We need to, measure it on any surface. Always, there is one remark: coefficient of static friction is higher. I will say to keep the motion is easier than to start the motion. Okay, I will stop here because I want to have like short videos, and I will record the second in a little bit.